Welcome everybody to start building Azure infrastructure with C#. Just gotta pop up today's agenda. I'm going to give a little bit of overview of Pulumi and infrastructure as code. Then I'm going to do a demo using Azure, using C#, and then we'll spend some time to answer questions. And that's a wrap. But I do have a fun demo, and I'm excited about this talk, about this workshop. So kind of the way I'm thinking about what I'd like to show you today is, I've written a program in C#. I like C#. I've written this, and I want to get it into the cloud. I want to get it into Azure, and I want to do that using C#. I'm going to show you why I think it's a good idea to use C#, but in part it's because I like the language. And so the program I have, I'll get into, but it's basically this. It is a dad joke generator. So I made a little C# program, and when I give it a keyword like .NET, it writes out using an LLM a little dad joke. Why did the .NET developer go broke? Because he lost his cache. The jokes are not all fantastic. One thing I've learned is that we haven't hit like AGI level comedians. But I want to take this program and I want to get it into the cloud so that I can share it with Engen, so I can share it with you guys. You can all generate your own lame jokes. So that's what I'm going to be doing today. So to do all this, for some prerequisites before we get started, need Pulumi CLI installed. I'm going to be using .NET 8. I saw somebody mentioning 9. I'm going to be using 8 because that's the one with the good runtime support in the Azure functions I'm going to be using. You're going to need the Azure CLI installed. You're going to need access to an Azure account, and you're going to need a Pulumi cloud account. Now, that's all if you wanted to follow along as we go, but by no means do you have to do that. You can just sit back and enjoy, and if you want to explore it later, feel free. But these are the prerequisites. So let's cover Pulumi infrastructure as code. If I wanted to get my code into the Azure cloud, the kind of recommended Azure way is to use ARM templates, which is a JSON-based format for describing your resources. I guess the first way I might try to set things up is not using ARM templates at all, but maybe just going into the Azure UI, clicking around, trying to upload my code and get it running there. That's great for kind of like exploring and seeing how things work, maybe for doing a demo or getting a feel for what's possible. But at some point, if I want to like productionize it, I want some way of declaratively describing what I'm setting up in the cloud. And to do that, I can use ARM templates. But look at them, right? This is not easy for me to read or understand. It is declarative. In this example, I am declaring a storage account. So like basically blob storage. But the description itself kind of looks like a blob. There's just like a lot of details here, and it's hard for me to follow. On the other hand, right, if I want to declaratively set up blob storage and I'm using C#, I can just pull in my Pulumi library. I can have the using for Azure native storage. And I mean, this is just so much easier for me to understand. So that's what I want to show today. To be more specific, what I'm going to show you when setting things up in Azure is a couple of different ways of doing it. We're going to use Bicep, and we're going to use Pulumi, and I'm going to show you how Pulumi makes for a better approach. But to overview ahead of time, right, ARM templates, as I just showed, are JSON-based, and they work only in Azure, and you run them from the local CLI. They are a bit verbose, so Azure also offers Bicep, which is a DSL that's a little bit less repetitive and is also Azure only. Terraform is another option that's common. In that case, you can use HCL, another kind of custom programming language, and the advantage versus Bicep or ARM templates is it would work on any cloud. But Pulumi, my obviously preferred choice, we can use a general purpose programming language, right? I'm going to use C#. And like Terraform, I can use it on any cloud, and I can use it from my local. And, we have some secret handling advantages. The big slogan that we like to use for Pulumi is your cloud, your language, your way. And by that, what we mean is if you're the C# person, you can use C# to set up things for your cloud, whether that be Azure, whether that be AWS, whether that be Google Cloud, right? Somebody mentioned Python. I'm also a big fan of Python, so you could use Python, right? You could use Python on Azure. You could use C# on Google Cloud. You can choose the tools that work best for you, right? Your cloud, your language, your way. Quickly, before I jump into a demo, the programming model, if you're not familiar, of Pulumi is as such, right? We're going to create a program. It's going to be a standard C# program, and in that program, we're going to describe some resources. We're going to say, hey, we want to set up blob storage. Hey, we want to put this thing in blob storage. Hey, we want to connect this thing up to that and read out values, for instance. We will have inputs and outputs to each of these. So an input into our blob storage might be like some binary we're storing there. And an output might be a URL that we can access that by. And then when we run this program, we will be applying those changes to the cloud. When we run that program, we do it with an instance. We create an instance of this description of the cloud, and we call those a stack. So you might have a dev stack, kind of like a dev environment or a QA environment or a prod environment. If this is confusing, I think it will make a lot more sense once I get into the demo. But it's a pretty simple idea. We're going to declaratively describe the resources we'd like to set up, and then we are going to, instantiate those into the cloud. Specifically, it looks like this. We're going to have a project. We're going to have our program.cs, and in that, we'll describe our resources. And then when we run our Pulumi up, the Pulumi engine is going to compare what we've described with the state of the world. And then it's going to apply, create, read, update, delete operations into our Azure cloud to make sure Azure matches the state of our program. All right, let's show some code. So here we have my project, which is called AZ C# app. And I have a little folder called CLI, and this is my CLI app, right? So if I change into it, I can do .NET run. And then it gives me this joke. Why do bicycles fall over? Because they're too tired. This is actually fairly good as far as the dad jokes go. Give that one a 5 out of 10. We can also give it parameters, right? So we can say Microsoft. Why did Microsoft make a great gardener? Because their PCs are always down to earth. They excel at planning. I don't actually understand that joke. Here's my code, right? It's just standard C#. The main part of it is this prompt where I tell it generate a clean or family-friendly joke, just return the joke and nothing else. Or if we provide a keyword, then we just apply that as well. And then it passes that to our model. Here we're using GPT-4o, and it makes the request here and returns it. The temperature helps set how creative the joke is. The max temperature is 2, and if you give like a very high temperature, the LLM will just spit out mainly gibberish. Very creative answer, but not very funny. So our goal, right, is I want to get this into the cloud. I want to get this into Azure. When I started programming in C#, it was C# 1.1. This was very early days, and Azure did not exist. And I spent a lot of time building graphical, user interfaces for this company I worked at where people did data entry. And, C#, I went to school, I learned a lot of Java, and then I got my first job and we did a lot of C# programming. And I really fell in love with it. Just a great language. And I think I also fell in love with Visual Studio. such a great IDE that was highly integrated with it. But now, right, it's years later, I haven't done C# in a while, and I'm trying to transfer these skills to cloud engineering. I want to get this running in Azure. I don't really know how. So first thing I'm going to do is I'm going to create a function app. So I've created a new folder, and in that, I've created this joke function. The way I initially created this joke function was actually just asking ChatGPT for some help on how to convert this to a joke function. But once it showed me the layout, it was pretty easy for me to understand. You mark something up as a function endpoint, and then you need to have a task, and you say what type of request it handles. So I'm going to do get and post, and the route is going to be a joke. And then I basically took my C# code and brought that in, right? So we get the keywords from the request. We need to get an OpenAI key, and then we need to generate our joke, which I do down here. And it's basically the same code as before. Once again, we can set our temperature and change it. Max tokens is just, you can limit how much it returns. And that's about it, right? So this is the C# code, and now, I need to get this into the Azure cloud. So there's a couple ways to do that, as I mentioned, right? So one way would be going into Azure, going into app services, doing create, going through all these steps, actually building my function into an app, uploading it, associating with this web app. That, as I said, I think it's a great way to get started. Probably not the right way past like an easy tutorial. So the next thing, actually, I should discuss the architecture. To get a function app working, let me see if I can zoom in on this. To get this function code working into Azure, I need to set it up in a specific way. What I'm going to do is build this function app into a zip file. This zip file is going to be placed in Azure Blob Storage. Then it's going to be given a URL. That URL will be publicly accessible, although it doesn't necessarily need to be. Then I will create a function app, and I'm going to be using .NET 8, and I'm going to be running on Linux. When a request, a function app is like a Lambda. So if you're familiar with AWS, function app is like AWS Lambda. It is an event-driven way to create a web service. We could do this many other ways, right? We could set up like AKS and set up a Kubernetes cluster and get things running in there. But we're just going to take our joke thing and put it in this function so that when a request is called on this endpoint, the function app will grab the zip file from blob storage, start it up if it's not already running. Then it's going to reach out to an OpenAI Azure component that we're also going to set up. That setup will give us an endpoint, and will also create an API key. So that when a client makes this request to our joke endpoint, the same way that we can do down here, it will run, but it will all be in Azure, right? It will pull down the zip that we've pushed up. It will make the call to Azure that we've set up, and it will return the results. So that's what we want to do. So step one, yeah, we create this function app. Oops. And that's pretty simple. It means mainly taking our code and moving it into this task format and instrumenting it correctly. So the next thing we can do, right, is we can use Bicep. So Bicep, as I mentioned, is a infrastructure as code solution from Microsoft. And it looks like this. So a problem I had setting this up in Bicep to give it a fair shot is that in ARM templates and in Bison, you can't actually upload blobs to Azure. That's considered out of scope. So if you would like to set something like this up using Bicep, what I needed to do is actually come up with a shell script that does some of the earlier steps. We need to set up our resource group, we need to, let's see. Oh, sorry, I wasn't at the top here. So if you want to use Bicep, it can work fine for certain solutions, but here, because I need to get that account, that blob into that account, I needed to basically make manual calls to the Azure command line. So I'm going to set up temp storage. I'm going to set up a storage key. I'm going to create a container, and I'm going to do my blob upload. Then once I've done that and I have my function app in place, I'm going to actually call my Bicep script, which will set up the rest of the, the OpenAI account, the GPT deployment, the Linux app service, and the function app. So this is a problem, right? If we want to use the suggested Azure way to do things, we can't actually come up with a declarative solution, because for this particular case, there is just not a way to upload blobs declaratively. By the way, I did this in Bash, but you can also do this in PowerShell. If you're a big fan of PowerShell, it might be the way to go. I like Bash a bit more. PowerShell, nice ability to pipe things together, but the syntax is always a bit confusing to me. Okay, so this is a possible Bicep solution. You could run it like this, and then afterwards, the teardown is a bit challenging because some of the things we were set up manually, so you could just delete by resource group name. Azure has this nice resource grouping where everything we create is sort of in a folder, and so we can remove it all at once. But the problem with this approach, right, is because Bicep isn't a proper programming language, we can't do arbitrary actions as part of our infrastructure setup. We lose declarativeness because kind of this complex logic has to be done out of band, right, in a shell script to the side. And this kind of reduces the elegance of setting things up in Azure, to me. Where if we had a fully declarative programming language-based approach, which we're about to set up, it's a lot easier to include ad hoc tasks in our setup. Also, super helpful, if we're working across more than one cloud. So let's say as part of the solution, we don't just need to set things up in Azure like we have here, but say we have to also set up a DNS record in Cloudflare. Well, that's going to be hard to do all using Bicep, since Bicep is Azure specific. But yes, let's move on to our next solution. This is what we're working for, right? So we're going to have a client that's going to call our function URL. So we're going to get our function app up and running on Azure. We're also going to get up running on Azure an OpenAI REST API. And so when this function app gets a request, it's going to post against the Azure REST API. It's going to return back the result to the function app, which will return it to us. But let's do it in Pulumi. So first of all, I'm going to create a new folder called infrastructure. Let's clear this. Any questions of interest, Engin? So we'll go.
So far not, but I got 2 feedback what people are currently using to manage the infra on Azure, and I got 2 feedbacks around Terraform. So people using
Terraform. Why can't? Oh, sorry. Yeah, Terraform. Thankfully, in Terraform, this blob issue I was talking about in Bicep would not occur, so you can upload to blobs in Terraform. You can't, though, do arbitrary programming tasks that you might need to as part of setting up your infrastructure. I think I will show a little bit of that. So I've created this infrastructure folder, and then I'm just going to do Pulumi new. And then I could pick AI here, and I could pick C# and then kind of describe the problem. If I was just getting started with Pulumi, this might be a good way to go. Like I need a function app in Azure. feel like my typing really goes downhill when I'm in these workshops. I'm not going to do it that way, but that's an interesting way to start. What I'm going to do is pick a template, and I'm going to pick Azure C#, and then I'm just going to pick the defaults here, dev stack. I'm going to do Canada Central as my region. And then we can see in this infrastructure folder that we have created, we now have, right, this CS project. We have this program, which I'll get into in a minute. We have this stack, right? So this is our dev stack. All that's in here right now is that we've set up the Canada Central location. And then we have our main config. The program is where our infrastructure is defined. And as you can see, it's just normal C#. We just are returning a function that when you run, returns a dictionary of outputs. So just standard C# code. And if we do Pulumi up, we should be able to apply the contents of this template, right? So this template just sets up a storage account and a resource group. A resource group being just a grouping that lets you group together all your related elements. So we'll do yes, and then it will apply that. The nice thing with this just being code, right, is if you are familiar with C#, you can just, you probably know how things are going to work, right? So I want to create some tags. Let's change this to author. We have at Pulumi, you're supposed to, that's actually not my email. You're supposed to make sure you know who created what. But it's easy to understand how I might tag things because it's just code, right? Like it works the same way that I would expect C# code to work, right? And if I'm curious about what the various arguments are or how I can change things, I can just click in and see, right, that the storage account takes the storage account args, storage account keys. And I also get the kind of, type checking and kind of red squiggly errors when I make problems that I'm used to, which is one of the big, it sounds small, but that's one of the big things that I appreciate. It makes it feel like something familiar and something that I can work on. Okay, so this created successfully. We can see in Pulumi app how things were rolled out here. But let's move on to our actual, like this is just a storage account. Let's work on our actual function URL. So I'm going to copy and paste a little bit. So I'm going to set up a resource group called dad joke. I'm going to set up a storage account. I think that maybe I should have some tags. Owner. And this way, I can just build out the infrastructure that I need. That's a capital T. So I have my storage account, which, I mean, if you're familiar with AWS, this is like your blob storage. I'm just calling it dadjokes.sa. We're putting it in the resource group here, right, that we are declaring up here. And then we're just going to start adding the additional properties we need. The nice thing about it being code, right, is just, we get all the advantages of our AI hype cycle to help us write this code. So it's suggesting an app service plan. I think I'm actually going to copy over some more code. So we have tags, we have storage account. just copy this over. So we're going to create our storage account. Next thing we need to do is create a connection for our storage account. The reason for that is because our function app is going to need to connect to it, because the function apps actually store some local state and some logs and stuff into blob storage. So I'm going to create my storage account. Next, I'm going to create my OpenAI account, which I'm calling Dad Joke OpenAI. We are going to set up a SKU for it. The GPT deployment I'm going to use is going to be GPT-4o mini. And I'm going to put it in my resource name. I'm going to call it GPT-4o mini. If you're familiar with OpenAI's various LLMs, 4o is like fairly recent. It was pretty popular before 5 came out. 4o mini is a smaller version of 4o. It's faster, it's not as smart, but it's very cheap and it's very fast. So it's great for something like this. So I'm going to set up my deployment, cognitive inputs, deploy property args. I'm going to set up OpenAI 4o mini. They have different versions of it. So I'm going to choose this version. And I'm asking for it to upgrade once the version expires. So you could actually not specify a version. And as they roll out new versions, you would get it. And then I'm going to set up a SKU. So standard, I don't think I actually want capacity 10. But the cool thing is here, when I built this out originally, I was just able to explore, right, and find the things I needed. I knew that I needed OpenAI, and so I could just start, using the tools, looking in Azure Native. See, it's already figured out for me. The thing that I tried originally was I was like, OpenAI, where's OpenAI? But in fact, Azure Native has it under cognitive services. Anyhow, once we have the OpenAI API set up, I'm going to set up an app. And for the app, I need an app service plan. Being like a Lambda, you can set it up to be provisioned so that there's an instance there always running, or dynamic. I'm picking dynamic. Then I'm going to set up my blob container to hold my package. And then the part that I could not do in Bison is I'm going to push to my blob storage my function app. Right? So back here, I have my function, right? I also put together this little shell script that just does a .NET publish release and then zips it up. And so whenever I make a change to my joke function, I can rerun this. I could actually include this script as a step here in my infrastructure. But right now I'm just hard code referring to it. But this will package up my blob. And the next step is to produce a URL for that. So the package URL, let me go back to my picture here. This function app is going to talk to blob storage both to pull down the code to run, but also to store logs and other state that it has. So pulling down the log is going to use this SAS URL. So I'm going to set up a URL. I forget what SAS stands for. I think it's signed URL. I don't know what the AS stands for. Somebody does, put it in the chat. But I'm going to set up this URL that points to my zip file, application zip, right? And the way that this all gets configured is right here. So I'm going to create my web app, same as we saw in Azure here. But now I can apply all the properties programmatically. So I'm going to say a new web app. I'm going to give the plan ID that I created before. It might be possible for me to inline new it here, which might be a little bit nicer. But yeah, here's my plan ID. I'm going to run it on Linux. Here's where I'm setting my .NET version. function runtime version. And then here, right, Azure Web Job Storage. So this would be the pointer to in blob storage where we're going to store all our state. The nice thing is, setting this up, there's a lot of particular details about how Azure works and how this is all set up. But actually, the way that I created a lot of this was just following the way the Pulumi library works and also getting some help from Copilot. But yeah, here's the storage URL for storing that data. And then here is our URL for actually pulling what it's going to run. Once I have those, right, the function can start up. But it needs...
Adam?
Yeah.
You asked for SAS. It means shared access signature, thanks to Patrick Pop.
Nice. That is a confusing name. Shared access signature URL. So we have our shared access signature URL here. And we tell the app that it's going to run the website from that URL. And then we also need to give it our OpenAI endpoint, which, because this is just code, right, we can just refer to up here where we created it and then get its endpoint property. The trickiest part when I was setting this up was actually getting the Azure OpenAI key as part of this. So I need to pass this as an environmental variable so that just like locally, I can access that. But to do that, I needed to inline here, reach out to the cognitive services account I set up and create a new resource group and get back a key. These are just a lot of specific details. They may not be relevant to what you're doing, but the point I wanted to show is like, hey, it's just code, and we can kind of explore with the kind of IDE functions we know and love, and even something that's a little bit intricate to set up initially, like this function app, is quite easy when you're working with the tooling that you understand. And then at the end of setting all this up, we need to return some values, right? So it's not that helpful to set this up and we don't know where it is. So as part of our Pulumi program at the end, we returned this dictionary with keys and objects. And here we are just going to access our app that we set up and return the default hostname. So this is an output value. You can see here it says output string. So once that is created, then we'll be able to access this output value and it will be returned. So this, in other words, is the full program to set up our structure here. And we don't have to dive into Bash or PowerShell or ad hoc scripts like we did with Bicep. I say all that, but like I assume that the reason that everybody comes to these is actually to see whether it will work out or fail, right? Like the moment of truth is whether the solution can actually be applied and run. So if we run a preview, it'll show us the changes we need to put this in place. So we're going to create the Cognitive Web Services account. That's our LLM. And then the app service plan. And then everything else is kind of either the storage blob or the web app. But let's see what happens. Let's roll this out. If it fails, well, that'll be exciting, right? Debug things on the fly. So you can watch it as it runs, applying things. We also have the Pulumi link here we can look at. So this is app.pulumi.com. Pulumi, is open source. App.pulumi is our commercial offering, but for free, for personal use, it's usually free within, it has some pretty generous limits. Oh, look at that. What did we get? The specific capacity of account should be at least 1. All right, this is where it gets exciting, I think, is when it doesn't work exactly as it did in practice. So if we go up here to our cognitive services, I think that we need to give it, what did it say? Capacity. Capacity is 1. Let's try that. So OpenAI, you can reserve how much LLM requests you think you're going to make. I thought that if I left out capacity, it would just not reserve any, but it seems like we have to give a value. So let's see what happens. Yeah, what I was saying is app.pulumi.com is a commercial offering, but free for personal use within certain guardrails. And it lets me see, how this is rolling out. And then I should be able to look in my Azure account if this is working. We can go back to Azure, go to App Services. So this one, I believe, is an earlier one I set up, testing this out. If this works, and if the Azure API isn't too laggy, which sometimes it is, we should see our new app starting up there. So far, so good. Oh, there we go. So it says it applied. It says that we have an endpoint here. So let's try it out. So we can access these outputs that have been returned by using Pulumi stack output. So if we just run output like this, we can see all the outputs, right? And then we can give a specific one, oops, like that. And then we can also just do standard mash things like that. And that doesn't look good, does it? But I think that's because I'm running the function app URL. And what I actually want is my joke endpoint. So drum roll, please. See what we get. There we go. Why did the bicycle fall over? Because it was too tired. I think that we already heard this joke, but it is working. And if we go here, we should be able. Why did the teddy bear say no dessert? Because it was already stuffed. Nice. So I can share this with the group. I can go back to chat. Should work for everybody. And we can also, we should be able to provide keywords. So suggested keywords, let's say Azure. Why did the cloud break up with the server? Because it found someone more Azuring. That's not really a joke. But it is working and it is up. Let's check what our Azure UI says. There we go. So here's our second one that I have set up. We can click in here. We can see the details. We can see the tags that I set up. No, that says backup. So that's actually, let's just confirm. Yeah, no tags. I guess I didn't set up the tags on this one. Activity log. Should be able to see if you guys are calling it. And there we have, right, a working app. So to review, right, I've taken this CLI app that's here, I've converted it into a function URL, and we've also written some infrastructure to set that up in Azure. And the infrastructure is, if we, okay, so we have like 11 lines of imports, but then we have like maybe 150 lines of code, most of which is just declaring these various resources that we need to set up in Azure. And the cool thing for me is, right, that our program and our infrastructure are written in the same language, so that when we do need to do programmatic things like zipping up that file and pushing it out there, or whatever else, right? If we needed to, say, reach out, open some Excel document and get out some firewall rules and set those up in Azure, like those kind of programmatic things can be done right alongside of our declarative infrastructure setting up. And if you're somebody like me who's used C# for a long time, like it's just exciting that you can use the tools you know and love, makes it feel right at home. If you're somebody who is very comfortable with Azure, and very comfortable with working with Terraform or various infrastructure as code tools. But you work in a larger organization where people have certain strengths of dealing with programming languages. Sometimes using a tool like Pulumi, where you can use a programming language, will allow you to bring in those people who are more familiar, right, with those tools. They'll be less scared of this than of some, crazy Terragrunt creation that's hard to understand if you don't live in it all day. And from here, like, you can do a number of things. So this is kind of an end-to-end example, but you can imagine in the real world, right? If you're at a larger org, probably not all your infrastructure would live in one file. You probably have some sort of base infrastructure, some networking stuff, some shared infrastructure, and then you may have some layers on top of that. Then you may have compute, various web services, maybe data pipelines. With Pulumi, it is possible to separate those out into separate projects. Then the person setting up this service might just need to bring in a infrastructure stack and then just set up their web service. And maybe their web app won't use the function web app, right? Maybe you have a preferred way on Azure that compute should run. Maybe it's in AKS. You can easily, because this is just code, put together a component, right? You can abstract over this so that all they need to do is call into a function with a certain location of where their code is, right? Or they just need to pass in something that says, I'm going to need access to Cosmos DB or whatever other infrastructure you're using. But I'm a big fan of code, I guess is what I'm saying. And code has the ability to abstract and to build building blocks that we can use to put together things in a way that is understandable. That's like the thing that I think is cool. That's the thing that brings me, here to Pulumi. But yeah, I got it working. The joke app exists. And let me now go back to my slides. All right. So the code can be found here if you'd like to check that out. And let's maybe tackle some common questions. Oh, I see a question here. Patrick Pop, how do changes to the infrastructure work? If I edit the infra code, does Pulumi not know to create a new function and just apply it to the current function? So that's a really good question. I think there's a couple ways to interpret it, right? One is, if we go back here, right, to this slide, when you're making a change to the infrastructure, Pulumi is keeping track of the current state of Azure, right? So in Pulumi Cloud, it has a state file, and it knows what's existing in Azure, and you can refresh that state if it gets out of whack for some reason. So when you add to your program a new piece of infrastructure, it's basically going to do a diff off of what it knows to be in Azure, and then decide whether it needs to do a create, read, update, or delete. And so that Pulumi preview that I showed was in the preview, it's showing like, oh, comparing the state, I need to create this, this, and this. And the way it decides, what the identity of things and how they line up depends on specific use cases.
Adam, what you could show is maybe the Pulumi registry, where you can see that some of the properties definitely trigger a recreation of the resource. And then depending on this one, you may have to decide, maybe run some blue-green deployments of changes to be sure that the old resource get not destroyed. So there are, I don't know if the cognitive or the web app, what you used, that could be, did you use Azure Native or the Azure Classic?
So this was Azure Native.
Yeah.
And I was using, this was web app.
There is it. Yeah. And on the inputs, there should be then written with a little sign, which you see there on top of it, there the little sign with the I, for example, resource group name. And this will trigger, for example, a replacement. So if you have any change in this one, then you may have to think about a different strategy to ensure you hit your SLOs.
And you can see this for everything within the registry. And so, yeah, it depends on the case, but it's something that is important to think about. And thankfully, we have that preview, so you can see what the changes are actually going to be. But yeah, sometimes that does require careful thought. Back to my slides. Somebody says, can we use Pulumi with GitHub Actions so we don't need to locally run the code? And what best practices to work with secrets and environmental variables? Yeah, so you can use GitHub Actions. I mean, you can run anything you'd like in GitHub Actions. So certainly, in terms of secrets, we have some great, I wonder if I have a slide. I may have a slide here. We have Pulumi ESC, which is a centralized management solution for secrets and configuration. And so this can be a great way to handle secrets, but you can also use Pulumi with other secret solutions. I don't know if there's a specific question you have about how secrets could work, but I would advise you to look into Pulumi ESC. So, yeah, so common questions we get are, how do you migrate to Pulumi? It depends on where you're coming from, but we do have some solutions. There is even a ARM to Pulumi solution, and there's also a Terraform one. They may or may not work well depending on your use case. I think the recommendation is usually like join our community, and if you're using Azure, if you're using AWS, join those channels, ask what's worked for others, because it can vary the best approach to migration. And I think we did cover Pulumi Cloud.
There's one question from Katja. Maybe have a look. Should I read it out loud? So how does RBAC management works? In example, assigning key vault secret read writes to a function app possible with Pulumi and C# itself, or do I have to do this manually and fall back to REST calls or so?
Assigning key vault secret read writes to a function app is possible. I don't understand the question. Do you understand the question, Engen? So is the question about RBAC in terms of Pulumi or in terms of Azure? I'm not sure. Maybe we could connect afterwards, and I could try to help you answer that. If you want to further your understanding of Pulumi, I also would recommend this Pulumi concepts page, which just goes through kind of a more extended version of explaining how we do that diffing, how identity is determined, and etc. I think it's easy to get started without mastering these concepts, but once you have SLAs and you have things running in production, I think it's important to have a mental model of how things are working under the covers. Yeah, what other questions should we tackle? That is all for my demo portion, for sure.
We don't have any further question in the Q&A tab, but maybe some ad hoc questions in the chat. Other than that,
Let's see. I'm scrolling through.
Can you show the destroy as a good cloud citizen, the full life cycle? So
yeah,
how does the destroy look? So your chance to DDoS the dad joke generator of Adam, but I think.
Yeah, is anybody using it?
I tried it. It's a little bit slow on my side, but I'm in Europe, so maybe that's. Oh
yeah, interesting thing I hit setting this up is that I set this up in Canada Central, which is like a Toronto data center, which is pretty close to me. But OpenAI only has the cognitive services are only available in certain data centers. So my OpenAI endpoint is actually in US East, which seems not ideal. But yeah, if you want to destroy, we're going to just do destroy. We have to spell it right though. This will pull down everything in our stack. You can see what it's going to do here. And let's do it. And as I mentioned, all this code is available in that GitHub repo. The Bicep code is not in there, but I can share that if anyone's interested. I just whipped that up out of curiosity. And here we can see the delete process. Even our blob storage is being cleared out. And there we go. If we try our URL. Sorry, what was that, Engin?
I said, yay.
Yeah. Engin's worried about the cost here. So if we refresh here, resource not found. That's it. All right, everybody. Well, thank you so much for coming.
One last question. Come on.
Yeah.
One last question from Patrick. How does Pulumi select which provider to support? Some small providers like Hetzner are available, but others like Netcap are not. So that's a good question.
Yeah, that is a good question. I would say if you need a provider and it does not exist, you could, in fact, create your own. I believe, Engin, you've created a provider.
So there are several ways. I just look up the documentation to paste it here. So you can so-called bridge the one provider which is missing. This what I did for some Terraform provider. If you need it ad hoc for some specific case, you can use here the any Terraform provider. So that's something. If you find out in our Pulumi registry there's the provider is missing or something like this, and you don't want to bridge it full because you don't want to support to expose this to the public, use the any Terraform provider, and this is going to create an SDK for your Pulumi program just in time created for your use case. So that's quite powerful. I use it now in several occasions where we don't have the dedicated Pulumi one, and this still helps, and it's a cool feature. I think we also made a workshop around this a couple of months ago and so on. But yeah, give it a try, and it should help you, Patrick, with missing ones.
We also have in our Slack community, which you should definitely join, there's a contribute channel. And so if you're looking to, contribute in some fashion, that might be a good place to join. There may also be a channel for Hetzner. I'm not sure. Somebody else asked the Visual Studio extension for Pulumi. I can't verify the signature. I mean, I can look into that. It shouldn't be the case, but yes.
Oh, that's good feedback. I will let's Adam pass this forward to our engineering department. That's a good thing. I use IntelliJ, so I'm not aware of Visual Studio things. So, but thanks for the feedback.
Perfect. Well, thank you, everybody. Join the community Slack. Say hello there. And yeah, thank you for joining this.
Bye.